Hello guys, in this video I'm going to show you how to calculate the average value of any periodic signal like a current or a voltage, for example, in an AC circuit, okay? In a very easy way, as usual, So there are always some tricks and, and tips to solve AC circuit in a very accurate and, efficient way as well, okay? And we're going to apply some tricks today in that example. This is actually one of your homework examples, in example 815, number D. So in that question or problem, it was asking for calculating the average value and the RMS value as well. So in that particular recording, I'm going to show you how to do like the average value, and the next video, inshallah, it's going to be about like the RMS value. Okay. So why I choose this particular problem? Because it's not like easy. It's not a straightforward. Okay. To apply like what you learn basically in that chapter. Okay. There should be like some transformation in the shape of the input, like waveform or like signal or like function, before you apply the definition of an average or even RMS in the next video. Okay. So let's see. So here we have a current. He called it I2 for some reason. Anyways, so it's equal to 4 sine 10t. So the first like angle, the first theta of a sine is basically 10t minus 6 sine square 5t. So the second angle is 5t, not 10t. So there are different angles here, okay? And this is basically amperes. It's not part of the function, okay? Anyway, so this is amperes. Okay, so how to do that? So let's write down the definition of an average, okay? And see how we can apply, okay? So the average of I of t will be like that, okay? 1 over the period. This is a periodic function, okay? He said so in the question. He was asking to find the average and RMS value of the following periodic function. So that's a periodic function. That's not our problem now, Our problem is to find the average and RMS. In that video, are average only, okay? So 1 over t is the period, or is it? Of I2 of t, okay? The integral from 0 to t, it's a limited integral. It has limits. The first limit is 0. Second limit is, the period. Then the function I2 of t dt. Okay, let's apply it. So 1 over t, we don't know t yet. 0 to t, we don't know t yet. Okay, I2 of t is 4 sine 10t minus 6 sine square 5t dt. Okay. Now how to find the t? Okay. So let's take a slide here. We used to see like one function like sine only or cosine only in all the examples we saw so far in the previous homework, and even the previous one, the first and second, and even here, okay? Now it's the first time to see a function that is composed of two functions, sine 10t and another function sine square 5t with different angles, okay? So we need to know t. Let's assume that another like value or another function, like for example I or v, whatever v of t equal to, like for example 5 sine, okay, 20t minus 5, okay, something like that. And we need to know the for example the period, okay? So we said that omega equal to 20 in that particular like example, and omega is equal to 2 by f. F is the frequency, and we know that f equal to 1 over t, the period in time. So 20 equal to 2 by 1 over t. So t is equal to 20 over 2 bar. That's it, right? So what is the problem in our example to apply such simple, very simple calculation to find t? Is that we have two functions, okay? So if we consider the first function, which is sine 10t, then omega is equal to 10. And from that, t will be equal to 10 divided by 2 pi. But if we consider the second term, sine square 5t, so omega is equal to 5, and from that, t will be equal to 5 over 2 pi. So there is a contradiction here. We don't know, right? So the solution for that is to unify the angle. Okay, the angle should be the same. Okay, so you have to convert, you have to translate that function, which is 4 sine 10t minus 6 sine squared 5t, into a function that has like same omega, or even like one sine or one cosine, you know, with one angle, and that's it. Okay, so how to do that? So there are two ways. I'm gonna do this in two ways, two calculations. One of them is basically easier than the other one, but let's see here. So there are two solutions for that. Okay. So solution one. So in solution one, we're gonna convert sine 10t into like some equivalent, but this equivalent, which is basically also will be sinusoidal wave, sine or cosine, but have 5t, not 10t. Okay. So let's see. We know that sine theta 1 plus theta 2 equal to sine theta 1 cosine theta 1 plus cosine theta 1 sine, I'm sorry, this sine theta 2. Okay, we know that equality. Good. How we can apply it here? So sine 10t can be written in that way. Can be written as sine 5t plus 5t. 5t plus 5t is 10t, right? So 5t is basically our theta 1, and the other 5t, this one, is our theta 2, right? So that's equal sine theta 1, sine 5t, cosine theta 2, cosine 5t, plus cosine theta 1, which is basically cosine 5t, sine theta 2, which is sine again 5t. Good, 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 good. Now they are equivalent. The first term is that guy here is equal basically to the second term. So basically sine 10t equal to 2 sine 5t cosine 5t. Okay, good, good. So let's now remove the sine 10t and put 2 sine 5t cosine 5t. Okay, so I2 of t equal to 4. Then we're gonna remove the sine 10t and put that. 2 sine 5t cosine 5t. So 4 multiplied by 2 sine 5t cosine 5t minus 6 sine square 5t amperes. So 4 multiplied by 2 is 8. So 8 sine 5t cosine 5t minus 6 sine square 5t. That's I2 of t. Oh, now every angle here is 5t. Okay? Every angle here in all the cosine and sine terms here are 5t. So we can confident with very great confidence to say that the omega is equal to 5. So omega here is equal to 5. And from that 2 by 1 over t equal to 5. From here, t is equal to 2 by over 5. So we can apply now the average. So then the average of I2 of t equal to 1 over t, 1 over 2 pi over 5. It's 5 over 2 pi. 5 over 2 pi. Then gonna have like very big like integral. So the integral from 0 to 2 pi over 5, which is t. Then we have 8 sine 5t cosine 5t minus 6 sine square 5t. Okay, that's very good. Now we should calculate this integral, right? Yes, we should do it, and some of you will just think, oh, let's like, distribute the integral. So this will be equal to the integral of 0 to 2 pi over 5, 8 sine 5t cosine 5t minus the integral 0 to 2 pi over 5, 6 sine square 5. Yes, that's correct. And you're going to do this by yourself, right? Uh, you know, uh, like manually. Now, we have again online calculators that will do that for us for free and also very accurately and very quickly. Okay, that we used to do in that course. We here study like electric circuits. So our concentration is to solve the circuit, not to solve the integral or find the RMS or basically find like, basically make some arithmetic calculation of complex numbers. So we have the tools that do that for us. Okay, so our online tool today is from Wolfram Alpha, which is basically a very big company. So okay, I have it here. It's already written for us. Okay, but we can do this from the beginning. It's fine. So I'm gonna just remove that part here. You can do it in like two integrals, but that's fine. So I just opened here a big bracket. You can also close that one. Okay. So the first term is 5 over 2 pi. You can just write 5, then slash. Let's do it. That's fine. Let's do it. 5 over 2. And for pi, you just write pi like that. It will be translated by the, you know, guys, here when you click equal, it will transform it into like a pure mathematical like expression, So you can review if your text is correct or wrong. Okay. Then our like integral 0 to 2 pi over 5, that's correct. Okay, the first term is 8 sine 5t cosine 5t. We have this term here, but we're going to have another term, which is minus 6. Then for sine square, do it. So sine square theta is equal to sine theta all square, right? So we're going to do that right in that way to avoid any confusion. Okay. So sine square 5t, it's a sine 5t, then the whole. So press control and number 6. Oh, that didn't work. Yeah, I'm sorry, not control, shift. Shift and number 6 and put 6 here. Okay. So I'm sorry, square, not 6. Okay. So shift number 6 will give you like the exponent to write. Then you write 2 in that exponent. Okay. Sine square 5t is basically sine 5t is a whole square. Okay. Let's review one more time. 8 sine 5t cosine 5t minus 6 sine square 5t dt. Okay. And for dt, you just write dt. Let's do it also. Oh, the d will be given, given automatically in the upside. You just write tb, after that. Okay. Then we write equal. The first thing it will do, it will basically write it in another way, more like mathematical way. So you can review 0 to pi over 5. Look, guys, here he translates the pi into pi, the symbol pi. 8 cosine 5t sine 5t minus 6 sine square. We are correct. 5t dt. Okay? Okay, that's equal to minus 3. And I know that's the correct answer because I solved it before. So average of I2 of t, which sometimes they write it in that way, I2 average t. Yeah, it's not, the average is a constant, so you don't write t anymore. So I2 average is equal to minus 3. Okay, that's, remember guys, that is the first solution, okay? So I have another solution. So the first solution, we converted the sine 10t into something that have 5t. So every sine and cosine term in your equation has 5t. You know omega, okay? You know omega is 5. You avoid any confusion, okay? Now let's do it in another way, okay? In that second way, I'm going to look at the sine square 5t and convert the 5t into 10t. So I'm going to remove the sine square 5t and put some sine and cosine as well. But this, like new terms, will have 10t. Okay. So again, we have the same unified like angle in all sine and cosine terms, so we can determine omega easily, and we can do the averaging or basically the integral. Okay. So solution 2. Okay. So in the first solution, we looked at sine theta 1 plus theta 2. We're going to look at something very similar, but now it's cosine. Okay. So we know, again, another quality that cosine theta 1 plus theta 2 is equal to cosine theta 1, cosine theta 2 minus, it's always the opposite. Okay. So you here added theta 1 plus theta 2, it's minus theta. Sine theta 1, sine theta 2. Okay. So cosine 10t, 5t plus 5t equal to cosine 5t, cosine 5t minus sine 5t, sine 5t equal to cosine 5t, cosine 5t, cosine square 5t, sine 5t, sine 5t, sine square 5t. So we end up that cosine 5t or 10t, cosine 10t equal to cosine square 5t minus sine square 5. Okay. And we know also that cosine square theta plus sine square theta equal to 1. From that, sine square theta is equal to 1 minus cosine square theta. So from that, we can say that sine square 5t equal to 1 minus cosine square 5t. Okay, so we're going to go back to this one here. Cosine 10t equal to cosine square 5t minus, we're going to remove the sine square 5t and put that guy here. 1 minus cosine square 5t. So minus 1, then minus would be plus cosine square 5t equal to. That is cosine square 5t. That's another cosine square 5t. So that's cosine 2 cosine 5 square 5t minus 1. Okay. Oh, I did a mistake here. So, okay. Yeah, we need to find the sine square, not the cosine square, because we are given sine. So I'm gonna go back a little bit here. When like very, so we're gonna go back to that. Yeah, that's step. So instead of saying like sine square equal to 1 minus cosine, I'm gonna do it in the opposite way. I'm gonna explain in a bit why I did that. So here I did from like 1 minute ago, it was cosine sine squared theta is equal to 1 minus cosine squared. No, I'm gonna do it in the opposite way. So I'm gonna go find the cosine in terms of sine. So cosine squared theta equal to 1 minus sine squared theta. Okay. So from that we can say that cosine squared 5t equal to 1 minus sine square 5t. Then we can compensate in the first equation, that equation here. So cosine 10t, I'm gonna remove the cosine and put 1 minus sine. Okay, so 1 minus sine square 5t minus sine square 5t. So that equal to, this is can be added with this one. So 1 minus 2 sine square 5t. So can go back a little, can go forward here. So we can say that cosine 10t minus 1 equal to minus 2 sine square 5t. Okay, divided by minus 2. So sine square 5t is equal to 1/2 minus 1/2 cosine 10t. Okay, that's not the end yet. So we're gonna go back to our original question. So we have here what? Sine square 5t. So we're gonna remove sine square 5t and put that guy here. 1/2 minus 1/2 cosine 10t. So that will be sine, the first term sine 10t. The second term will also have like something with 10t. So again, we unified the angle. Okay. So we can rewrite I this time. So I 2 of t equal to, the first term will stay the same, 4 sine 10t, 4 sine 10t. Now the second term, it is 6 minus 6, and it is sine square 5t. So it will be 1/2 minus 1/2 cosine 10t. Look, guys, everything now is 10t. Okay, equal 4 sine 10t minus 3 minus 3 cosine 10t. That's I2 that we're gonna like find the average for. Now we can apply, easily the integral. Okay, because we have a unified angle. So omega is 10 this time, and the t will be 2 pi over 10. Okay, just one like note before we go forward and solve that integral. So let's write as the integral. So the average of I2 of t, which can be written as I2 average, equal to 1 over t, then big integral, 0 to omega here is equal to 10. So 2 pi over t equal to 10. From that, t is equal to 2 pi over 10. Okay, so 2 pi over 10. And we can remove the t here in the beginning and put the equivalent 10 over 2 pi. 1 over 2 pi over t, it's 10 over 2 pi. Then we have 4 sine t minus 3 cosine 10t. Close the parentheses, put dt, close the big bracket. Then we can distribute the integral, So 10 over 2 pi. We can have 3 integrals, 0 to 2 pi over 10, 4 sine 10t minus 0 to 2 pi over 10, 3 minus 0 to pi over 10, 3 cosine 10t. Yeah, and there is dt everywhere. Don't forget the dt. Okay, we have 3 integrals. We can go easily on word frame mathematics or math and solve it. But before we go forward, if we review the chapter, okay, The first thing that you're gonna learn that any sinusoidal wave, either cosine or sine, when you integrate it over its period, the result will be zero. Okay, so without going forward, this guy here is equal to 4 integral 2 pi over 10, which is the period sine 10t dt. That should be equal to 0. Okay, and this guy here, again, 3, 0 to 2 pi over 10 cosine 10t dt, also equal to 0. Okay, I'm going to explain why. If you have a sine wave like that, I'm going to just draw one period. Okay, the average means, or the integral actually means, the area under the curve. So you have here some area, which is positive, right? And you have here also same area, but negative. So they're going to cancel each other. This is for sine. For cosine, it's something like that. Let's draw it again. It will be something like that. Okay. So that's area in the middle here is negative. And we have here this guy and this guy. When you add them together, both are positive and they have the same area, same shape like the negative one. So again, they're going to cancel each other. This is for cosine. So always the integral of 0 to t sine omega t dt equal to 0. Same, 0 to t cosine omega t dt also equal to 0. So without doing any well-framed math or something, I to average equal to 10 over 2 pi. Okay, then the first term is 0, 0 to 2 pi over 10, 3 dt minus 0 again. Okay, so 10 over 2 pi, and let's do this like simple, like so minus 3, and this will be t, and the limits are 0 to pi over 10. So I to average equal to 10 over 2 pi minus 3 multiplied by 2 pi over 10 minus 0. This guy will be multiplied or cancel out with this guy. So minus 3 again. Of course, solution 1 and solution 2 must be the same, right? But of course, as you see, solution 2 is much easier. We were too lucky, that we choose. Yeah, whenever you have like a sine or a cosine only term without multiplying or squaring or stuff, the integral will be easy because it's always 0. It's always 0. Okay. So that's basically, guys, how to find the average. One last thing we're gonna do, of course, if you have some doubt about this, again, let's do well-framed math. Okay. So let's do it in well-frame as well. I actually have it, so I'm gonna just review with you. So here it is. Yes, here it is. So let's review and see. So in well-frame, okay. So 10 over 2 pi, first term 0 to pi over 10, 4 sine 10t dt. Okay. Second term minus, you just switch the second and third, that's fine. So the third is written first. 0 to 2 pi over 10 cosine. Actually, this is minus, but of course, because it's 0, it doesn't affect, so that's fine. Minus 3 cosine 10t, and third term is minus here. So this is minus or positive. Accurate here. Yeah, that's what. So this is positive. Yeah, because there is a minus here, so minus with positive will be minus. So that's minus 3. Minus will be positive. So, but it doesn't matter because basically it's gonna be 0 at the end of the day. So here is 0. I'm sorry, positive. Okay, and okay. So let's did it equal. First, it will write it in a mathematical way, so you can review. And yes, it's correct. And finally, it is minus 3. Okay, guys, that's basically how to do the average value of current or like, basically any periodic signal, okay, and how to use well-framed math online calculator again to find it accurately and very easy way. Okay, guys, that's it. So next video, I'm gonna show you how to do the RMS. Thank you very much for watching and see you in another video. Bye bye.